Super fun. I'm making a video here for this problem that gave me trouble. I know we spent a lot of time in it earlier. I'm going to do it again. And it was in 6.2. The problem was a couple things. Well, I had a silly mistake to begin with. Well, before I go on, let's just get in here and take a look real quick. Another problem here. Number 14. There it is. You guys should be able to see that okay. Thank you. Mobile dashboard. All right. And we got this problem here. It changes every time, right? And I can look at the solution if I wanted to. I'm not going to. We're going to work this out. We're going to do it the right way this time. And this time here, I'm going to zoom in a little bit. And I'm going to also take a snip. So we're going to go into one note here. You guys can't see it yet. But I'm going to go into OneNote here. I'm going to click the snip button. And I'm going to snip this thing. We're going to get this whole... You know what? I'm going to get two. I'm going to do two snips. So here's one. There it is. And then I'm going to get another one with our beautiful diagrams. Okay. There we go. And now we're going to just hang out in here a bunch. We're hanging out in this guy. Okay? And I'm going to make this much better than before. Promise. First things first, I think I want to click on this guy. And I want to make this bigger. Okay, and I guess I have to drag this one to make it bigger. I want this there. That's good. I want a fairly big picture. I don't mind moving it over a bit. There. That's going to be a little bit nicer for us. Now, a couple things. First off, let's read this again. And I'm going to explain my mistake. Okay. What I was trying to do, I didn't read it very carefully. What I was trying to do, and if anyone wants to speak up, I don't have my let's see, is anyone in there right now? Oh yeah, let me turn the volume up here. I can barely hear you. Wonder why. Okay. Okay. So cool, awesome. So anyway, what was I going to say? Oh, yeah. Okay. So what I'm going to do is, here we go. Let's read this first. Come on. Okay. Go over my mistake, and then we'll do it the right way. Okay. Because what I was trying to do is I was trying to make this triangle here, I was trying to make that my cross sections. And who knows, that might work. I spent a lot more time filling with this. It might have worked to say, oh, you know, I'm breaking these up. And into all these little cross sections here. Whoop. And they all look like this. There's a bunch to going over there, getting bigger. That might be a way to do it. But the way I did it wasn't right. You can't see my OneNote? Here, that's weird. Let's try this. Well, that's a pain. Let's try this. Let's try this again. Share my screen. Oh, screens. Here we go. This will do it. This is what I want. There. Okay. Now can you see it?
Yeah, I can see it.
Okay. That was all right.
Yeah, it was incorrect.
I'm learning. Okay, so I got out of the sound channel, I got back in. Hopefully it's good now. So here I was trying to do the cross sections saying, hey, you know, these guys, these right triangular prisms. And that might work, but the problem is we're given that there's some radii here. We're given that, hey, maybe this radius is this one right here is, I think in this problem, we're saying it's 20. So in this problem, we're saying this is 20. And also, I was assuming that the radius of this is 20. Now there's a problem with that, right? To say, hey, the distance from here to here is 20, and the distance from here to here is 20 is not right. And that was my mistake. Now to make that really clear, why that is not true is really easy if you think about it like this. You go, hey, that. Now we are given that this distance. Let me fix that. We are given this distance here, right there. We're given that that's 20 for sure. Like the base of this, the radius is 20. But now how could that be 20? And again here, I need to be better with my length. So how could that be 20? And this distance be 20 when clearly that creates a right triangle? Could not, right? So that was my mistake. That's why even after we fixed it and I got a new expression and we took the integral, it was still wrong. So that was a big wrong assumption on my part. So let's do it the right way. And I'm recording this, and it will. I'll find a way to share it with you guys one way or another. So a wedge is cut out of a rectangular, circular cylinder of radius 20. So again, we know it's 20. And let's erase this. That's not 20. Okay. One plane is perpendicular to the x-axis. To the axis of the cylinder. One plane is to the axis of the cylinder. So I guess the axis of the cylinder is the one going straight through it. So one plane is perpendicular, so the y. The other intersects the first at an angle of 30 degrees. Oh, I'm sorry, the planes. So the plane on the bottom and then the one intersecting it like this. And that making 30 degrees. And that's where we get this cross section here. We got a 30 degree right there. So that's 30 degrees. And that's given that we know is true. The other intersection, intersects at angle 30 along a diameter of the cylinder. Find the volume V of the wedge. Take rectangular cross sections. Rectangular. See, and just in case you don't know, because apparently I didn't. What's wrong with me? Here would be a rectangular cross section. They look like rectangles. Okay. So let's do that. Let's go ahead and follow the directions. Now, I have done these types of problems and done different cross sections. If you can manage it, it's fine. But we'll do it this way. Okay. And it's saying that it's parallel to the line of intersection of the two planes. So here's the line of intersection of two planes. It's going to be parallel to that. So it's going up and down to this. And so what I'll do is I'll draw a picture. Let's see here, we can zoom in on this a picture a little bit. And I'm going to draw what those look like. Because that is where we're having trouble. So let's say we'll go up here and then go like this. And then we'll go right up here and go like that. And so here are our rectangular cross sections. There's one right there. Hopefully that's a little bit more clear. I can zoom out a little bit. And now you can see, okay, that's one of the rectangular cross sections, and they get kind of biggest in the middle, and they get shorter down here, almost nothing. They get real tall here, but at the very end, they're going to be kind of short. They're really high, but the length is not very, very big. And hopefully that makes it way more clear. There's my rectangular cross section. Okay? As we're getting these guys, and they're floating along. So one more view that would be really helpful, helps us a ton, is the very, very top view. So that's where I'm going to go down here. I'm going to say, you know what if I'm looking at this cylinder from the very top? That's going to be super helpful. And have a beautiful semicircle to show. So kind of looking at above the wedge. And we know our rectangles are going right here. Like here would be the base of one of our rectangles. Right? That rectangle there, the bottom, is right here. Okay? And now we're given a couple things. We're said y. Here's y. That's this distance. So let's say if I'm here, there's my center. I got this here, this distance. I got this distance here, and we know what those are. Those are 16. And we know this distance. It's y. That's this right here. Right here, that's y. So do I know the length of this rectangle? Yes, I do. Because if I take a look at just one of these, that's a right triangle right here. Right triangle. I get 16. I get y. And so this must be the square root. Oh, now I'm doing 16 again. Why am I doing 16? It's 20 in this problem. I did 16 before because the one we did before was 16. So let's make sure I'll stick to 20 here. So 20, 20. So this is going to be the square root of 20 squared minus y squared. That's this distance. Now, if I want the whole distance of this rectangle, it's twice that. Get it? Okay. So we're setting it up. Now, if each rectangle, let's call it R. So I'm gonna sum up the areas of all these rectangles. And right now, let's say this is y sub I. Y sub I, y sub I. Because the y is what's changing. This y is going to change each time. So I want to add up all these areas of all these rectangles. And so right now, the rectangle is going to be some base. So let's say that R sub I is really going to be some B sub I times some H sub I times, and then the width is obvious on all these, is that's our delta Y. Okay. Base, I already figured out. This length is this 2 times this, because that's one of them. So 2 times this. So right now what we got is the sum. Okay. The sum of 2 times root, and we'll make that 20 squared 400. 400 minus y sub I squared. That's the b sub h. Now the h you know what? This is going to be right here. H sub I, that's right here. And hey, this is a 30, 60, 90 triangle, so I already know this. 30, 60, 90. They always follow the form of n, 2n, and n root 3. So if n root 3 is the same as y, how do I get the opposite side? Well, I have to divide by root 3. Because I times n by root 3 to get this side. So if I know this side, I want to get this side, divide by root 3. So h sub I is just y over root 3. And that is the height. This right here, go back to our picture. If you look at this height of this right triangle is the height of my rectangle. So that's why we're looking at this. So y root 3 is my h sub I. So times y sub I times root 3. And then, what's my delta y is delta y. This would be, right here, one rectangle, and it depends on my y. So if I had a shorter y, like if it was way down here, I could draw a quick sketch maybe. If I had a really short y right here, then this would be my rectangle, right? This would still be 16. This would still be 16. And I could still find the length of this and the height. If I had a larger y, not 16, 20. If I had something close to 20 for my y, so let's say it's like 18, well then now this would be the top. I'm getting a rectangle right here. Rectangle cross section. That's going to be a little shorter. So that y is changing. So the y is changing from 0 to 20. So I can take what I wrote down here in red and make the integral that will surely give me the right solution. Integral from 0 to 20 of 2 root 400 minus y squared times y root 3, y root 3 dy. And that surely does work. That is not too bad. Right click, copy. Yeah, and so anyway, I feel like, why not? Let's just paste. Hey, let's do it. Just for fun. We got time. Why not? I'm making a recording. You guys still with me? Anybody? Okay, is it making sense? Okay, cool. And so let's just do it. So the integral from 0 to 20. Let's see, the 2 I can pop out, and the root 3. So 2 root 3. And then I got root 400 minus y squared times y. And then this is where, dy. Might need to use a substitution, a u sub. No, a trig sub would work, but I'd rather not do a trig sub. So I haven't done that. Let's see here. If we did u equals root 400 minus y squared, u squared would be 400 minus y squared. squared minus 400. And y would be root. Or, let's see here, 2y dy equals 400 minus 2u du. So let's see here. So I got y dy would equal 400. No, I think this would work. 400 minus, oh, actually, divide both sides by 2 would be 200 minus u du. There. Does that make sense? So I said u is this whole mess, and I squared both sides. And if I square both sides and then take the derivative, I get 2u du. Oh, I'm sorry. Well, actually, I went here. So I solve for y squared. Take the derivative here, and you get 2y dy equals 400 minus 2u du. And I got my sub again. Sub y dy. And I can sub in u. I think I should be able to actually do this integral. 2 root 3. Oh, now if u is this, we have new limits. So when x equals 0, u would be square root of 400, which is 20, right? When x equals 20, u would be 0. Interesting. So we'll go from 20 to 0 of u, and then y dy is 200 minus u no. I don't know. Now I'm not feeling that's right. I'll finish this later. Go over that with you. But this is the setup. This is the setup. This, I don't think this works. Because the du needs to be multiplying everything. It's not. So like for instance, if I did this, I'd have had 2u du equals. Oh, wait, what am I doing? Man, I can't even take a derivative. How sad. Derivative of 400? What's the derivative of 400? 0. Yeah, there we go. Jeez. Pathetic. All right. So actually, I should have had 2y dy equals negative 2u du. Yeah, so I can barely hear you, but divide both sides by 2 here, and I would have gotten y dy equals negative 2u du, And that would be fine. So now I can fix that.
Yep. Yeah, that would be fine. Yep.
That would be fine. So now we can fix that. See, I'm doing these mistakes on purpose so you guys can learn, right? This is how you find your mistakes. So, okay, we got two. So now this was u. Y dy, I got it right here, is times negative 2u du. And there we go. And so let's do this. 2 root 3 times the integral of, and we could go over 0 to 20. I'm just going to leave it 20 to 0. Who cares? Of negative 2u squared du. And let's just take that out front. So I got negative 4 root 3 times the integral from 20 to 0 of u squared du. Integrate that. And we get u cubed over 3. 20 to 0. Well, that's easy. So we're going to get negative 4. The 0 is 0. So negative 4 root 3 times negative, plug that 20 in. Oh, sorry, this should be times negative 20 cubed. So 2 times 2 times 2 is 8. 1, 2, 3. Over 3. And we get 32,000 over 32,000 root 3 over 3. Okay. And I'm sharing my screen, so here, let's take a look. Let's try it out. Hopefully we didn't make any whammies this time. 32,000 times root 3. Wait, was it times root 3? Let's go back. Root 3 over 3. All right. Let's submit. Come on. No whammies, no whammies, no whammies. Aw, what? 20. All right. Here, so I'll go ahead and show you guys. I must have made some silly mistake again. Ridiculous. Oh, nope. Where did it go? WebAssign. Oh, okay. So here, if it was 10. They have a different U sub. Oh, yeah, I could have done that. But 0 to 100. We had 0 to 400. That was right. Let's go back. Oh, no. Oh, well, we did a different U sub, though. But in any case, actually, let's just... I don't want to spend any more time on this. I'm sure there's a silly mistake in here.
Didn't we say that h of I is y over square root?
Oh, did I? Yeah, and there it is. Yes. So h of I was y over root 3, and I put y root 3. Once again, I'm just making tons of stupid mistakes today. Yes, thank you. So that was a mistake. Which means I wouldn't have had a root 3 out here. I'd have a over root 3. Which means this guy would have been right here. Right?
See, that should do it.
Let's try it.
Because I just barely caught on to that too. I see that.
And I just
Y is I over square root 3.
keep
Y
doing.
square root 3.
Yeah. So here, WebAssign. Let's just log back in here, and we have another attempt. Fill in. And it was student view. That way we get the same numbers. (6.2) number 14. Come on now. 3. Let's try it. Root 3, because I can't follow my own work. All right. There. Submission 2. It says it's wrong. Uh, 20 times 20 times 20. 2 times 2 is 4 times 2 is 8. Four times 8,000 over 3. Y over root 3, so it'd be 2 over root 3 over here, and none of this would be different. So we had u, and then let's see, y squared would be 4n minus u squared. 2y dy would be negative 2u du. Y dy would be geez.
Y dy equal negative u du.
There it is, yeah.
We have 2y dy equals negative 2u du divided by 2 on both sides.
So
gives us
negative u.
negative.
So this would be, yep.
Be that's
So this would,
have been the error.
yep, there's another one. So this would be negative u du. So it'd be just negative u squared. So, okay. So it would be negative u squared. And this guy, all right, would be, and we already talked about, this wouldn't be y root, this would be y over root 3. So this would be 2 over root 3. That would be 2 over root 3. That would be 2 over root 3. So now it's 2 over root 3. And then that negative we're taking out front. And it's u squared. So again, negative 2 over root 3. And we get this. So negative 2 over root 3 times negative 8,000 over 3 would hopefully be 16,000 over
3 square root.
There we go. Solution 3. Third time's a charm is what they say. Who are they? Don't ask. Hey, there it is. All right. Finally. Oh my goodness. We got it.
It worked out.
Such a fun problem. Awesome. Yep.
I can go to sleep in peace now. Thank you.
Yes. Now you won't be up late at night. There is the work. We finally fixed it. All the dumb mistakes. My goodness. But we know how to do it. So there we go. Okay. See you later.
All right then.
I'm going to cut out here.